Hello everyone and welcome back to the series of Digital Logic Design. Today we will study a 4-variable kmap. For any 4 binary variables, let's say w, x, y and z, we have 16 possible binary combination and corresponding to these we have 16 minterms. Therefore, the map of 4 variable consists of 16 squares as shown in figure A. Now the same map is redrawn in figure B to show the relationship between the variables, squares and their binary values. The rows and columns are numbered in the gray code sequence because in this sequence only one digit changes between two adjacent rows or the column. The minterm corresponding to each square can be obtained from the concatenation of the row number with the column number. For example, the number of the third row is 1 1 and the second column is 0 1. When they are concatenated or joined, they give a binary of 1 1 0 1 and this 1 1 0 1 have a binary equivalent of 13. So the square in the third row and the second column represents minterm M13. If you look at the map, for every square, the binary value, the minterm and their designations are also given. Now for simplification purpose, the map minimization of 4-variable Boolean function is similar to the method used for the 3-variable functions. Like at first, we will define the adjacent squares. All those squares who have a difference of 1 bit are known as adjacent squares. Like previously, we have considered the map of 3 variables lie on a surface whose left and right edges are connected. Now in case of 4 variables, it is assumed that the map is considered to be lie on a surface with top and bottom edges as well as left and right edges are touching each other to form the adjacent squares. So we can say that the row wise M0, M2, M4, M6, M12, M14 and M8 and M10 are adjacent squares. Similarly, for columns M0, M8, M1, M9, M3, M11 and M2 and M10 are adjacent squares. After defining the adjacent squares, we will make a group of adjacent squares. The combination of adjacent square is useful during the simplification process and is determined from the inspection of 4-variable kmap. If we use a 1 square, then 1 square represents 1 minterm and this will result in a term of 4 literals. Or if we make a group of 2 adjacent square, then the simplified term will consist of 3 literals. Or if we use 4 adjacent square, the simplified term will consist of 2 literals. And similarly, if we make a group of 8 adjacent squares, then the simplified term will consist of 1 literal. Or finally, if we make group of 16 adjacent square, then the function will be equal to 1. In the given example, you have to simplify a given 4-variable Boolean function, whose minterms are also given. At first, a 4-variable kmap will be drawn, which will have 16 squares, and all the minterms listed in the sum are marked by 1 are shown in the figure. Now we will make the group of minterms. The 8 adjacent squares marked with 1 can be combined to form a single group and the simplified term associated will be consist of 1 literal, that is y prime. Now the remaining 3 on the right cannot be combined to form the adjacent squares because the adjacent squares are formed according to the power of 2, which means that they can be 1, 2, 4, 8, 16 and so on. So the remaining 3 must be combined as a group of 2 or 4. But we also know that the more adjacent squares in a group results in a more simplified term. So for the remaining 3 minterms, we will make 2 groups of 4 adjacent squares. And here we will also reuse the already utilized minterms, because adding more adjacent squares to the given group results in minimum number of literals in a term. So after forming 3 groups of adjacent squares, we will simplify individual group for the simplified term. The group 1 has 8 members, so the simplified term will consist of 1 literal. And among the 8 adjacent squares, the dissimilar variables are w, x, and z. And the variable whose value is constant throughout the 8 terms is y and have a value of 0. So the corresponding term will be y prime. In group 2, the variables whose values are constant are w and z, and similarly in group 3, the variables whose values are constant are x and z. So the simplified function will be y prime plus w prime z prime plus xz prime. Now in the next example, we have to simplify the given Boolean function, which is in the standard sum of product form. The overall function consists of 4 variables and as expressed consists of 3 terms with 3 literal and 1 term with 4 literal. Now we require the canonical form so that we can place all the minterms in the map for the simplification purpose. Or we can express each term with 3 literals in a map by 2 squares. For example, the first term consists of product of a prime, b prime and c prime, and the last variable d is missing. So we will introduce the missing variable d with a value of 0 and also with the value of 1. And the same procedure will be followed for the second and the last term. In the second term, variable a is missing, and in the last term, variable d is missing. Both variables will be introduced in the corresponding minterms with a value of 0 and value of 1. And the resulting minterms will be placed on the map as shown in the figure. Now if we remove the repeated minterms, the final minterms will be 0, 1, 2, 6, 8, 9 and 10. And the given function can also be expressed in the form of sum of minterms. Now after placing the minterms in the kmap, we will make group of adjacent squares and will simplify them. So here we have 3 groups. The first group consists of 4 minterms corresponding to row 1 and row 4 and column 1 and column 2. The second group is formed by all the minterms at the corner, and in the last we are left with single minterm, so we will make a group of 2 adjacent squares by reusing a minterm. And after analyzing group 1, group 2, group 3 for dissimilar variable, the simplified function will be equal to the sum of b prime dot d prime, b prime dot c prime and a prime dot c prime dot d prime. Thanks for watching the video and stay connected for more interesting videos.